under the name of Kunal Malavali. We're also a software-only company. We're dedicated to providing software solutions for replication, data protection, and specifically today we'll talk about how that works with different virtualization environments that are in the marketplace today. It is the Scout product. We are headquartered in the United States. We do have offices worldwide. There are several patents surrounding the technology that we will be discussing today. And really the focus of the replication that InMage does is CDP, or continuous data protection, meaning that data is constantly flowing and constantly monitored and being protected. We're also heterogeneous in the environment, whether it's servers, storage, virtualization platforms. We're very open to the different environments that you may have installed within your organization. And it is also continuous disk-to-disk backup. One of the things that we like to do before we get started is we like to remind everybody that a disaster is not necessarily a huge event. In fact, the majority of disasters are reported to be, power failures, hardware failures, even network failures. And so whether it's a whole site or whether it's a single machine that needs to be protected, InMage is here and we have a solution for that. We have the capability to fail over an entire location into a new DR, dedicated facility, or just that one critical server. It might be that database or that application server that runs the business. We can certainly focus in on that. So really the unique value for InMage is it is network-based, block-level, asynchronous, continuous replication. So it is network-based, meaning standard TCP/IP. There is no additional magic that needs to be done within your environment to route around the replication. We are fully NAT compliant, and we really just sit on top of however your organization is designed today from an IP infrastructure. It is block level, meaning we're monitoring every block of change as it occurs at the storage level. We're recognizing just the change information, and then we're replicating that change information to a target server. Whether that target server is local or whether it's remote, it does not matter. It is asynchronous replication, so distance is not a limitation. And again, it's continuously being monitored, so we capture every millisecond of change as it occurs. Really, InMage is the only unified software solution based on CDP, or continuous data protection, that solves 5 critical recovery challenges. Whether it be disaster recovery, that full site outage. Perhaps you have several machines to hundreds of machines that need to be failed over into a DR facility and they need to be brought online. We have the capability of doing that, both physical and virtual and mixed environments. We also have the capability to automate the power on cycle rotation. So you may have critical servers that need to come on first and less critical servers that would then follow. And so we have that capability to set priorities on that recovery option. We have application availability and consistency points in those applications. It's one thing to just replicate the bits and the blocks from point A to point B and have them available. But what InMage does is it actually works and integrates with several applications, whether it be SQL or Oracle, as well as several virtual machine instances, to ensure that the application level is consistent. So ultimately, when you go to recover your data, not only will the server power on or the guest machine power on in the virtual environment, but the application that's running within that guest machine will be in a consistent fashion, and it'll come up and be ready to handle production transactions, whether that be SQL or Oracle, SharePoint, Exchange, it doesn't matter. We can also do local continuous backup and recovery. It does not have to be to a remote location. We can do any combination of to local or remote. We can also do backup or replication for failover in mixed environments, virtual and or physical environments, or any combination that you might have. Something unique about InMage is we do have the ability to go from virtual machines back to physical machines as well. So if you do have that one physical server that might need to maintain physical, and you do want to protect it in the DR location with a virtual machine, knowing that if you use InMage, you have the ability to recover that machine back to the production environment onto its physical platform if needed. We have WAN optimization built into the product. It'll optimize the replication of that data, It'll monitor the replication, give you full control over how that replication is being handled. It also gives you time constraints. For instance, you can set policies that say, allow a certain percentage of my total bandwidth during business hours, and then maybe a greater percentage after business hours. A simple example might be 40% of my bandwidth during business hours, and then after business hours, go ahead and use 90%. And then you can also prioritize servers. Perhaps the database server is the most important in your environment, and you want to prioritize that machine to ensure that that information is not throttled and it is replicated over to that remote site as quickly as possible. From a platform support perspective, we are an enterprise product supporting all Windows, several Linux distributions, as well as all the Unix distributions out there. Not only at the server layer, but in the application layer that you'd find. We certainly work with SaaS providers and cloud-enabled providers as well. From a virtualization standpoint, we focus on VMware, Citrix XenServer, and Microsoft Hyper-V, having integration into the hypervisor level of each of those machines. We also will work with other virtualization engines that are out there. One of the new things that InMage has introduced is what we call sparse retention. Really what happens when you're dealing with continuous data protection, or that CDP, is you're saving every millisecond of change information for a period of time that you want to retain it. The ultimate goal of doing that is you have the ability to roll back your data to any specific time down to the millisecond, and you can present that data. So you can simply say, show me what my data looked like 10 seconds ago, 10 minutes ago, 10 days ago, 10 months ago. And it just depends upon how much information you've retained in order to roll back to whatever period of time. Traditional CDP, that uses a fair amount of storage to keep, a month, several months, or a year's worth of data. So with InMage, we've introduced sparse retention, which ultimately retains fewer application points as the data gets older. We really give you several tiers of customization here. You could set up a customized policy that might say, for the first week, give me true CDP, meaning every millisecond of change is needed. Maybe for the week following that, you're going to maintain an hourly recover point. Or maybe for the month following that, you're going to maintain a daily or a weekly recover point. And then to the end of the year, perhaps you maintain a monthly recover point. Ultimately, what that does, it allows you to extend your recovery time window greatly without using a lot of additional storage. And more importantly, the speed of which it takes to recover that data is also very quick and very fast. So you do have customized capabilities with that sparse retention option. We are block level replication. We are only monitoring the changed blocks. We're not even replicating full blocks of information. We're simply looking inside the blocks and finding just the changed pieces, the deltas, and we're replicating just that delta information. We really want to keep that recovery point objective and the bandwidth very low, and that's why we're only focused on sending the deltas of those changed blocks. Within InMage, there's no rehydration needed from deduplication. Again, we want to keep that recovery time objective as low as possible, and we also don't need to rehydrate that data before recovery. When you select a moment to recover, it's simply a matter of presenting that server and it comes up and it's ready to go without rehydration. There's also no need for deduplication because we're only monitoring the changed blocks to begin with. We are not replicating any redundant information. We're not capturing any redundant information, and therefore we do not need to go through a deduplication process. Therefore, the entire replication process is more streamlined and efficient. Here's a small list of common applications that we see for protection: Exchange, SQL, Oracle, SharePoint, MySQL, even BlackBerry Enterprise Server. We have object-level recovery capabilities of each of those machines, and we also have full system capabilities, whether they're in a clustered mode or whether they're in standalone mode. Ultimately, the goal is to minimize the data loss and the downtime and keep that recovery point objective and that recovery time objective as close to zero as possible. In the next few slides, we'll talk about some architectural examples that we have. InMage is a host offload solution, meaning that there is an InMage data tap that resides on the servers, and there is a second tier of architecture called the process server. The process server does all the heavy lifting. It does caching, queuing, compression, encryption, the bandwidth management, all the reporting. Basically, all the capabilities of the replication is done on that process server. The ultimate goal is to make that data tap as lightweight as possible. All it does is it monitors write changes. It does not actually do anything as far as interfacing with the blocks themselves. It passively recognizes the change information, duplicates it on the fly, and hands it off to that process server so that it can be processed. In this example here, we're going to highlight the capabilities of replicating into one of the non-supported virtual machine environments. That would be a non-VMware, non-Hyper-V, or a non-Citrix Xen. There are many options out there that some people like to use. We recognize those environments by working with the guest machines directly. Again, the data tap installs on those guest machines, and it simply receives the block level changes, writes it down to storage that's been provided there, gives it all the capabilities of creating consistency points at the application level. You have all the capabilities of rolling back to any point in time and presenting that data. InMoj also has a control server that can be located at the secondary or the remote site. That control server actually manages the environment. In the case that there's a full site failover, you still have the web UI that you interface with, and it knows how to bring each and every one of those servers at the remote site online very quickly and very easily. Also keep in mind that InMoj does help with backup offload, so we can offload to tape. We simply centralize a replication. It might be local as represented here, and then we can hand it off and work with a numerous amounts of tape providers to ensure that you have that longer-term archive retention for anything greater than a year that you might need. The next solution, we talk about Hyper-V and Citrix Xen. At this scenario, we're going to talk about a non-disruptive DR test that you could do with these two hypervisor environments. Essentially, we work at the hypervisor level with this environment. We do have the data taps that are installed on the actual hypervisor machines, not the guest. We simply select the point in which you want to recover your data. Again, that could be a few minutes in past, or it could be several days or months in the past. Once that point is selected, we simply present an instance of that virtual machine as a guest. The users then can connect in full read-write capability on that guest machine, whether it's a SQL database, whatever it might be, and they can interact with it. It might be a user acceptance test environment. It might be a development environment. It might be just an audit check to ensure that replication is going and you do have your data. The key thing to remember is when that's presented, replication is still progressing during a DR test. This is non-disruptive. So you're still getting all your protection capabilities while you're validating and using an instance of that data. Because of the virtual snapshot, it does not require any additional disk space. InMoj can present that data real time without breaking replication and without using any additional disk space and provide it in read-write mode. Ultimately, when you're done with your test, you simply remove that instance. All the snapshots are deleted and everything's cleaned up. And again, you never broke replication, so replication is still headed there for you. As we talk about VMware specifically, VMware has a group of APIs that we can call and tie into to work at their hypervisor level. With VMware, we have an environment established with a vSphere and the primary site. Whether that's a standalone ESX server or a clustered machine, it doesn't matter. We also have the additional capability of doing a real-time P to V convert in the environment, taking a physical machine into a VMware environment. That would be represented by the database server in the upper left-hand corner. Essentially, this process includes at the remote site, within the vSphere environment, we create a master target server called the vContinuum target. Ultimately, that's where replication is going to reside as we replicate that information at the block level to the remote site. How we would establish this is you simply select the servers, whether they're within the vSphere environment or whether it's a physical machine. You select the servers to protect. It'll automatically push the InMoj data tap if needed. It'll then take a copy of the metadata of those machines, and it'll actually build an instance of those machines, whether they're already virtualized or whether it's a P2V convert. It'll build an instance of those machines in the vSphere target. those will be ghost machines. They will be built, but they will not be powered on. The next thing we do is we provision storage to that vContinuum target that equals the amount of storage needed from the servers that are being protected. So ultimately, that vContinuum target will have a handful of virtual disks attached to it. And where replication comes into play is we take our same block level replication and we send it down into that vContinuum target. Again, we're taking all the same capabilities where we're triggering at consistency points at the application layer, as well as making sure that the guest machine will boot up successfully. This is where you would sit in a day-to-day protection with that information replicating down to that vContinuum target. When it comes time to present that data, you simply select the one or more servers that you'd like to present. You pick a point in time and roll back the storage to the specific time that you've asked for to present that data. At this point, for a failover, the data would be disconnected from that vContinuum target. It'll be attached to the appropriate guest that you're bringing online, and then we'll be able to power on that machine. We can make any metadata changes as needed. So if you needed to update the CPU, the memory, the IP, the VLAN segment, anything like that certainly can be updated on the fly as we bring this online. This is simply an example of a failover where we detach that storage. We still have the capability, as presented in the previous slide, to do a DR test where we do not have to detach that storage and we can continue protection and replication. I would like to jump into an abbreviated and a quick demo right now to show you how we can present this information. Today we're going to be using the VMware solution and tying into that. And we'll simply go through some instances of the web UI as well so you can see that. As the screen refreshes as I connect into the lab here, the first thing that we're going to see is we're going to see the web UI, the web user interface that manages everything within the environment. The first thing that we have is we have a very simple pie chart that tells us the status of the overall environment on this overview dashboard. We also have a list of servers that are under protection here, and they can give us details about the servers. If we were to select into those, we would get details in them. With VMware, we have an additional user interface called the vContinuum interface. The vContinuum interface actually queries and works with the APIs of VMware. We simply select the plan that we want to manage. We tell it that we want to recover that plan. What it does is it filters out all of our servers and only represents the VMware-specific servers here. At this point, we can simply select one or more servers that we would like to recover. We can go ahead and choose the server we'd like to recover. In this case, I'll choose a SQL server. The next thing it does is it actually queries that master target server, and it wants to know at what recovery capabilities it has, meaning where are its recovery points, those consistency points that are taken at the application level, in this case it's SQL. It wants to know how far back in time we can go, and it's going to query all of that information and provide it to the interface here. Ultimately, when it's done doing that query, we have some quick options up here in the right-hand corner. We can select the latest tag, which is the last known good application consistency point. Ultimately, that's what we're going to do today. We could also select the latest time. That means send me the very last millisecond of change that's been appropriately applied to that target machine. And additionally, we can select a consistency point at a specific time in the past, or we can select a specific time. That is then returned to the interface. I then run what we call a readiness check. What a readiness check is, it actually validates the information within the vSphere environment, as well as on the master target, as well as on that ghost guest operating system that we built. And it's going to validate that everything's running, that everything's fine. It'll ultimately return a status report. If there were an error in that status report, it will provide us with information to resolve that error or some troubleshooting tips that we can look at. You can see everything was successful. There is no corrective actions needed. We can simply give this a name. It's a cosmetic name to monitor the recovery aspect. I'll select Next. Here is where I could change the IP information or the VLAN information. I could simply come in here, And I can even modify this. It's not going to matter. And then we'll give it a gateway. And then if we had multiple VLANs, we could set that up. So I'll change that on the fly. We also have CPU and memory information that could be modified. When I choose next, I have the option of recovery. We do have the ability to recover more than one server. If I were to recover more than one server, they would be listed out right here. And I would be able to select a modified recovery order. I would also be able to then select one of two options for recovering. The FX job-based option means I have more than one server, and there is a recovery order that needs to be obeyed in bringing those online. The option that I've selected, which is the WMI option, is to be used when you have one server or when you do not have an order of operations that needs to be obeyed. It basically is a broadcast command to all the machines to say, go ahead and come online as quickly as you can. At this point, I'm going to move this interface off to the side a little bit, and I'm going to bring up the vSphere environment here so we can see from the vCenter perspective what's going on. Within the vSphere environment, if we look over on the left-hand side, the bottom half of the environment is the DR location. We can see that we have this Scout MT, which is the master target. That was the vContinuum target where all of that information is being replicated into. Next, we see a handful of ghost machines that are set up here. We're actually working with the DR_SQL server. So ultimately what's happening right now is we're working with the master target. You'll see some tasks start to happen down below. It's identifying the appropriate disk drives that are associated to our SQL server. It's going to roll those back to the time that we've requested, which is the last known good consistency point. It's going to detach those drives because we're doing a failover. It's going to detach those drives from the target server. It will attach them to our SQL server, and then it'll ultimately power on that SQL server, and we can connect in and watch that boot up. If this were a P2V process, everything is identical from a user interface perspective. There's one additional step that we have is that we will install the VMware tools into that server for you so that we essentially when you boot up, you can take advantage of some of the optimization that those VMware tools will provide for you. This time we'll go ahead and open up a console here so we can see this machine booting up. It looks like everything's attached and it is powering online. And so ultimately what we'll do is we'll wait for the Windows to go through its boot process. This process, as far as how long it takes to boot, depends upon a couple of things. Depends upon how far back in time you're going. The further back in time, the more changes that need to be undone, so it takes a little bit longer. It depends upon how the raw horsepower capabilities of your ESX server, that hypervisor server, how fast can it handle that transaction and that I/O. And so ultimately, those are the two things that will determine how quickly a server comes online. It does not matter how big the server is, whether it's several hundred gigs or whether it's a terabyte in size, the speed at which it takes to power on is the same. In this lab, it takes about 2.5 minutes to bring a Windows 2008 server online. We'll allow that to apply to settings. Other scenarios that we could do while we're waiting for this is if you are doing a DR test. We have the capability of presenting this machine, again, in a very similar fashion to what we're doing now, but we would not break replication from that master target server so that you could bring this machine online and you could simply do any changes or any updates to it in a test environment. Those updates and changes would not be saved permanently. Go ahead and log into this machine here. When you're doing a DR test, you can do any changes, and then ultimately, once it's done, you release the presentation copy, and any changes you've done are removed with it. Once we log in, we prompt the event tracker so that you can track this appropriately as needed. And ultimately, because this is a SQL server, I'd like to power on the SQL and make sure that the SQL is actually running and that we came to a consistency point on this failover. So I'll go ahead and launch our SQL server. And there should be a couple of simple databases that we can connect into to make this happen. So you can see SQL powered on just fine. There was no complaints of inconsistency. We do have the InMage database here. Let's see if we can get in there with some tables. And we'll do a very simple select statement on one of these tables here. I actually have a cheat file that we can grab. So I'll go ahead and open that. One thing I do want to highlight is with the virtual environment, we are protecting the system volume as well as any data and log volumes. So any updates that are applied to the application, whether they're service packs or to the operating system itself, are going to be completely protected, and when you bring this online, will be applied there as well. This process runs the same whether it's Windows or Linux, and so we have this capability, and the process is the same there. We'll go ahead and execute a command there, and you can see that we do have data. It came up no problem. So by running this abbreviated test, we were able to see that we failed over SQL Server in just a few minutes, and we were able to present that data, and it was consistent and accurate at the application level so that we could start processing transactions right now. You'd simply need to redirect your network information, and you can handle these transactions. In a real DR scenario, we have full capability to fail back into the production site. So if this were a real DR scenario, you bring this server online, you start accepting transactions, the updates, you then want to maintain and keep those transactions, and you want to be able to recover those back into the primary location once that disaster has been recovered from. At that point, we simply can establish replication in the reverse, and you can bring everything back into the production site, and we have a process that we call a planned fail back that will bring us back into that scenario. At this time, I do have a few minutes left for some questions. So if there are any questions in that chat section, go ahead and please enter those in there, and I will be happy to answer those for you. One question that has come in is with respect to VMware, and it wants to know which versions of the VMware hypervisor are supported. Actually, any licensed version of VMware is supported. It does not have to be the enterprise level. It can be any licensed version. The free version is not supported because part of the issue with the free version is VMware has locked up the APIs that we use in order to go through this process. So that's a great question. Any version of VMware can be supported there. Another question we have coming in wants to know if we have support for Hyper-V 2012. Yes, we do, actually. Hyper-V 2012 is supported at this time, and we actually have a lab of that environment running that we could show at a private location if we needed to. So yes, Microsoft Hyper-V 2012 is supported. At this time, I'll go ahead and wrap up the discussion portion of this. If there's any other questions that come in, I will make sure that we get responses to those. I do appreciate your time in joining us today, and hope that you have a wonderful rest of the week, and we look forward to working with you. Please feel free to reach out to InMage at any time at sales@inmage.com or 1-800-646-3617. Thank you very much.